We have just started the broadcast, and the question I wanted to ask has been answered. It has been answered. The recording has started. So
Okay,
the webinar is being recorded from now. Okay,
perfect.
okay. Uh, so we can later decide if we cut it or just let it go as it is.
Okay.
Okay. So the last check, you can see my screen.
Yes,
You can see me.
I can see you. Yeah, I can see the presentation and I
Yes,
can
yeah,
see
the
you.
presentation. Yeah, is there's the first slide, and as usual, I guess we will switch the cameras off somewhere after the first two slides, right? Because
Yeah.
it's maybe we believe that the important things are happening on the slides,
Yes.
not in front of the cameras. Okay, that's great. Yeah. Let's do that. So it's 3 minutes to go. Still, we have 3 minutes, but
Mm-hmm.
it seems things are working. Yeah. So yeah, let's
Yeah,
do that.
last
Yeah.
checks. Okay.
Yeah. And by the way, Radek,
Yeah.
when I'm looking at those handsome guys in the first slide, right
You
here,
mean on your right?
both of them,
Okay.
and we are not getting any younger, Radek. That's 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 the CFD fault, right? That's what CFD does with handsome guys, right?
Yes.
They're getting ugly, and
Yeah. Yeah.
yeah, that's not fair. And software
Although we,
development, that's definitely what's happening with people when they because there are a lot of issues, right? And
yeah,
troubles and exceptions, and you have to stick
exactly.
everything together and
Exactly.
keep
Yeah.
it
Yeah. Yeah. It's
and
infinite
jungle with
struggle. Yeah.
too many balls. Yes, and those pictures are what old? Like 2 years old, maybe, I guess
Maybe a
something
one and a
like
half.
that. I have still the
It
same I
goes
have still the
it
same
goes
t-shirt,
quick.
right? And I can see. Of course, you are still really good, Radek. You look good, but
No,
I,
no,
I
no.
I feel older somehow. It's crazy, right? It's crazy.
Yeah, I think we use some
Yeah,
filters on these images,
it's
right?
the CFD software's fault that we made it so bad.
Yeah,
Okay, but the software is perfect. Just buy it, everyone. Yeah, it's really great. It's
definitely.
really great. Software is great, but the bill has been paid,
Yes.
which is our our health, right? Yes. Okay, 1 minute to go. Okay, let's do that. Let's do that, Eric. And we should be, we should, yeah, we should make it. We have party afterwards, so think think about the party. Yeah, it will be great. Pills and beer. Yeah,
It's in the fridge.
likely
Yeah.
a large, huge steak, right? So let's
Okay.
do that. We are looking forward to it, and also we are looking forward to this webinar, right?
Okay, so let's make it quick, 5-10 minutes, and then we will
Okay,
leave for pub
okay, yeah.
coffee.
Or maybe we can leave the presentation somehow, the slideshow on auto run,
Okay,
and
or
leave.
run some of our AI
I would
agent,
do that.
right,
I would go.
to make it.
Yeah, but still,
No, no, no. We are looking forward
no. It's
to
our
it,
job,
right?
and we like it still.
Yes,
Yeah, it's not bad
yes.
actually. Yeah,
It's great.
it's not its fault actually, right? We are getting older. Yeah. Okay, it's 3 p.m. I think we should start, Radek. It's
Yeah,
finally here.
definitely.
I think we will cut it here anyway, so we
Final
can say
countdown.
anything. We can say
Good.
anything now.
Okay, so no. Next time.
Okay. Okay, sure. Yes. Okay, let's do that. So what now? I'm sharing my screen so I can just present. I think I
Yes,
can.
yes,
I think
yeah.
okay.
I can
Okay,
see the
let's do
first
that.
slide.
Yeah. Okay, let's
So
do that. Yeah. Yes, and it's really here. Yeah. Okay.
okay,
Okay. Hello, everyone. This is Luboš Pirkl from CFD Support, and I would like to welcome you to the webinar where we will introduce the new version of TCAE, which is our software, and we are extremely happy to introduce it here in this webinar. Together with me on the line is our head engineer and the brain of everything, Radek Maca. Hello, Radek. Are you with us?
yes, I am with you. Hello, Luboš. Hello, the audience. Great to see you here.
Yes, Radek. What a pleasure to have you. So let's do
My
that. Let's
pleasure
do that.
too.
So okay, the new version TCAE 2603 is here. And yes, once again, enormous effort, enormous time has been spent on the new version. We did a lot of new things and we are excited to show it. So make yourself comfortable and think about what you need in your projects, what you need for your engineering simulations, and we will show you what we have, and let's see if we can put it together. So, okay, so the webinar is being recorded. The recording will be later made publicly available on our YouTube channel, and likely it will be sent to you in an automated email. So, yeah, so there's a recording. There is also there will be a Q&A session dedicated to your questions and our answers. So feel free to ask questions, and we'll be happy to answer them, of course. So you can ask during the webinar. We will still in the webinar we will pick the most representative questions which we feel that are important for the audience. There all of the questions will be answered. So yeah, all the questions which might not be that relevant, we will answer them via email. And of course, you can ask us anytime afterwards, after the webinar. Just send us an email and we'll do our best or to answer it or schedule a meeting or whatever, because it's you which makes our living. So yeah, so we are interested what you need, and we'll be happy to help if we can, and do definitely our best. Okay, I think those are the initial yeah information, and let's move in the webinar. So here's the agenda of today's webinar, and we will do what? Yes, there will be in the beginning there will be a quick necessary introduction from me. Then I will share my thoughts general about TCAE, about yeah us, the company, and also I will look into the future a little bit, and that's my contribution. After me, Radek will come up with the technical details and a couple of examples what exactly is new in the new TCAE version. And after that we will have the Q&A session which will be yeah answering your questions, and then we will conclude. So that sounds to be yeah like a good plan for about 1 hour of our time, of our valuable time. So let's do that. Radek, I think now maybe it's time to switch the camera to
Yeah,
to let the audience yeah see the presentation. And if we recall it, we can come back to Q&A. Maybe
yeah,
it's better if
definitely.
we can shortly yeah as
Good.
with the Q&A we can come back with the cameras if we recall it. Okay, so let me start with the necessary introduction. Don't worry, be happy. I will do only the necessary stuff, not to torture you too much. So
Perfect.
what is what? CFD Support is the name of our company. We are located in Prague, Czech Republic, and over 16 years we have delivered more than 300 or hundreds of consultancy projects for real industrial yeah, projects. So it's a lot of consultancy we have done over 16 years, and on top of that we have delivered more than 50 many years aggregated of software development on top of open source. So you can imagine how much work has been done over the years, and this experience counts, and that's what works for us definitely. Well, what we do is that we deal primarily with CFD. We also deal with FEA and FSI. We do a lot of optimization and acoustic simulations. So these are our main fields. I will talk about it more in detail a little bit later in this presentation. Our flagship product is software, which is called TCAE, which is it's a comprehensive simulation environment, which yeah allows users to yeah run CFD simulations and engineering simulations. Uh, in fact, it's a system. Uh, the TCAE is a name of system of software modules, and these modules they work together to create a comprehensive simulation workflow or engineering workflows, and users can play with them, right? There's module for meshing, there's module for FEA, there's module for CFD. CFD is the center of everything. It's primarily about CFD, but FEA can be used with it. Acoustic module can be used with it. Uh, Optimization module can be used with it. External software, whatever can be used with it, and it can be used in many different ways. TCAE is extremely flexible. I'm not going to go too much into the details, but it's extremely flexible. You can play puzzle. You can use just one piece of it, or all of them, or none of them. But still, it's extremely flexible. It works together with in-houses. It works together with other commercial codes, and it's really, yeah. The point is it's flexible. It's unlimited, so the typical user can use it for unlimited number of users, jobs, and cores. So our users are corporations. So we deal with companies. So the companies typically buy our software and can use it for unlimited number of users, jobs, cores, unlimited hardware to use the resources to the fullest. That's the really great benefit. We're focused. We never say we do everything. TCAE is actually focused on, especially on turbo machinery applications, on external aerodynamics, and on acoustics. So it's definitely not a general purpose code for everything. It's focused, and it allows us to be accurate. We are obsessed with accuracy because only if you put enough effort and dedication, patience, experience, and skills into one pack, then you can be accurate, and you definitely have to be focused. That's what we do. TCA is perfectly automated. It's really highly automated. It can be used in all ways. It can be used as a black box, so you just put the data in and pull the data off, or it can be used as a totally high-end software where all the sophisticated science is used. It's almost completely open source, so it's not, nothing is hidden. So it perfectly works with research projects, and it's everything is transparent and open and ready to use. There are definitely a lot of ways how to use it. It can be used on laptops, desktop computers, PCs, clusters, clouds. It can be used remotely from home, from work. It can be used in Windows, in Linux, and all combinations. It works in the graphical interface. It can be used in the batch mode, in the terminal. So it's really from the beginning designed to be very widely used on all major platforms. That's important for us. The knowledge transfer is important part of TCAE. So there's a know-how we deliver together with TCAE. So TCAE is not just a software; it's actually a partnership in exclusive club where the knowledge is transferred. So we have benchmarks, we have more than 50 tutorials which are ready and which are based on real engineering projects we did in the past. We have really good technical support and video manuals and PDF manuals and everything. So there's a lot of stuff we transfer together with software. Another important thing is that TCA is based on open source. So the code is open. Of course, I would say the automation part is proprietary, and we use licensing on it. But all the sticks are open source. So that's a really important thing, because that's why we are a relatively small company, CFD support, but our biggest benefit is that all the software that has been developed everywhere in open source, we can use it and we can transform it into something which works commercially. That's a really big thing. So in a relatively small team, we use open source, and on top of existing open source like OpenFOAM, Calculix, ParaView, and more of them. There is more than 60 of open source projects in TCAE. we have delivered on top of all those open source more than 50 many years of consistent development in a team, which is really, really huge contribution, and it allows us to offer this value to all of you. So that it's crazy how much effort has been spent on it. Over 16 years, more than 50 many years of consistent development in a team. Okay, today we have here the new release. It's the release called 2603, and it's the big one. It's a really big one. We normally say it's big, but this one is the biggest of the biggest because we have completely updated almost everything in TCAE. There's a new open form which we practically everything has been changed and updated. So there's large open form update. No stone remained unturned. Really, everything is new. Now, one of the biggest changes is that the old good AMI uh, mesh interface, arbiter mesh interface, was completely replaced with NCC, which is non-conformal stuff, and it gives us the new levels of accuracy, and the new it makes wider the possibilities of applications we can use simulations. We have added multi-phase VOF support to TCAE, which was never there before. We have added new tutorials. You can find them on our website, so feel free to visit our website where you can see a lot of details and a lot of free content which you can download and try yourself. We have also updated ParaView to the latest ParaView 6.1, and altogether we have improved or enhanced more than 100, and we resolved more than, in our system we have resolved more than 100 issues. There are small of them, there are bigger ones, so really a lot of new things have been done. And this is just a general talk, and Radek will introduce them later in this webinar. Okay, so let me continue with, there's a lot of ongoing development in at CFD support at the moment. So I will just briefly mention what we are doing at the moment, what has not been released yet. Uh, Definitely the biggest project running in at CFD support, or I would say, okay, really big project running at CFD support is new module called T-Base, which is technically a database. It allows users to store all the data, all the simulations in special databases, and this is really important for the times which are here, which are coming, and which are going to happen. We have to save the data. We definitely have this. We have to save the data in a smart way. Of course, we have to find a smart way how to store the data in the databases, because what? Because later we can learn on them. We can learn, we can use machine learning, we can use AI later. So we definitely have to store the data in a smart way. We have to store the essences, the setups, and the lessons learned in a special databases. This is what we are working on at the moment. It's really great. We have first version which are really great, and we allow users to save everything, especially for repeating projects or for products. It's absolutely necessary to store the data and to be able to come back anytime. And on these databases, employ the machine learning, use surrogate models, and also to use data extrapolation in seconds, and avoid really demanding and costly simulations. So surrogate models, T-base, definitely a big deal for the future. It will be necessary for everywhere. So we are working on it. We almost have it, and I think I can promise it that the next major release will include T-base, because it's already on the table. So T-base is one big thing. The second big thing is called T-brain. We are not sure, it's not clear yet if whether it will be a module or it will be everywhere. That's not sure. What I'm not what we are not sure yet. But T-Brain is another big project running at CFD support. It's an intelligent AI agent, which is it's really great because it eliminates the need of expert knowledge. It helps users to basically manage the simulation through the natural language control, through similar to ChatGPT. It allows to talk to the software in your natural language, and it works because it knows everything and even more. And it seems that we will be able to share our experience gained over those 16 years and hundreds of consultancy projects. It seems that we will be able to share this knowledge with the software, and the future will be absolutely yeah uh, yeah will be really different from what we have now, because now you have a system of software, then software engineer and and the success depends on engineers skills, experience and dedication. And now it seems it's changing because it seems that we are able to teach the software to have to carry on the experience in it inside and share it with the users. So the the biggest problem of all engineering simulations is expert knowledge, and it seems that this barrier, expert knowledge, will be somehow replaced or modified, or the level of it in the next version. So we are excited of this AI agency inside these engineering simulations, and we are happy to share it with them. Also, T-Brain will be likely released still this year. So it's an amazing time we are living in, and we are happy to prove it. It's those are not just empty promises. We are happy to prove it because we are living it daily. Uh, okay, so what we can expect is extreme simplification of engineering simulations, and we can expect extreme automation. So most of the clicking boring steps will be done automatically because the agent knows what to do. It's really great. So these two projects, we are also focusing in physics. We are turning our attention. We succeeded in some grants also. So we are turning our attention a little bit to biological flows, blood flows, non-Newtonian flows, hemolysis, blood pumps, also other parts of human body, human airways, for example. So it's one research vertical, I would say. We're excited about it quite a lot. We will also continue support TCAE Lite. So TCAE has a light version which is designed for individuals, and basically it's more general than TCAE. It's lighter. It only has TMesh and TCFD modules. It has a reduced technical support, but it's extremely cheap. And yeah, the goal of TCAE Lite is to develop in a way to be like graphical interface for OpenFOAM. Let's see how much dedication we will find for it. But it's here. It's released together with every TCAE. So there's out also TCAE Lite 2603. Yeah, we had to skip the annual license, which it was too cheap, and it led nowhere. So we keep only the perpetual version from the version 2603. So the light is here, and what else? So those are ongoing projects. Even more to the future, I can tell you that I already said it, but CFD is changing, and all the engineering simulations and all the technologies and all the world is changing very quickly, and the pace is only going to to accelerate. CFD support focus will for sure remain in turbo machinery. We will stay open source based. We will deal a lot of with optimization, automation, and AI driven workflows. What could be changing also with us is that we will be more focused more in decision making. We will transform more into decision partner because software is something which is more and more resolved. So we will turn our attention from the software more to added value to help our clients have better decisions. We we're we're moving, yeah, from simulations to decisions. There will be, instead of a few designs, there will be more exploring of design spaces. It will be, everything will be more complex and more based on decisions than on particular one designs. We will help our users to navigate in complexity, which is only growing and will be growing faster and faster, and it's uh, really difficult to keep the pace. So we will help navigate in the complexity of engineering simulations, and we will also help with knowledge maintenance, because this is really important, because the knowledge, there's a lot of data everywhere, and we will help, we will gather together the knowledge, the simulation knowledge. We also know the way how to put it in the software and how to keep it inside our company, and we will be knowledge hub and knowledge maintenance advisor, I would say. That's definitely changing, and yeah, that's it's what it is. Okay, thank you. Thank you, everyone. The real expert is going on the stage, and I will ask Radek whether he is still with us.
Yes, I am here and ready for my part.
Okay, Radek, that's great. That's
So,
really great. And I will do my best to click on your face and click make presenter. That means
okay,
that
let's
I'm
wait.
handing over
Okay,
the presentation over to
perfect.
you.
Something is happening, and let me know if you can see my screen.
Yes, we can. Radek, the stage is yours.
Great, thank you. Okay, welcome again. And now I would like to show you the main features which we have implemented from the previous 25.10 version, and what changes we have made, and what all new functionalities and features and visualization stuff are in the new version of TCAE. So as Lubos already mentioned, we have made hundreds of commits, which counts dozens of improvements, of robustness improvements, bug fixes, and mainly new features and new functionalities development. So there are dozens of them, and during my part, I will show you the most visible one, the most visible new features and functions which you can directly use, and which can be seen and can be used. Besides of that, there are dozens of really hard work behind, including the development, including the changes in the code, improvements of the code, uh, tailoring the code to the new OpenFOAM, as I will show you, to the new ParaView, etc. So I will show you just the main features. So here's the list of them, what I am going to present, and I will go step by step and everything we will present. So first, visible change you will see when you open new TCAE is the new ParaView. So we have again implemented and compiled for TCAE, so it's fully applicable and fully compatible with TCAE. If you would like to know what is new in ParaView 6.1, then you can go on the Kitware GitHub and see what is new. So you have the list here. What are the new features? So they made a lot of renderings enhancement, plugin updates, and filter changes. So you can go through all of them and see if something is interesting for you. And many of these new features you can use for enhance your workflow and visualizations, etc. So this is new ParaView. So anytime you will use the new version, all these new features will be available for you. With the new ParaView, we also implemented the project state saving, which was missing for a lot of our users. So now what is possible is to save state. So it means so you can save the layout, the visualization you made. So everything then can be loaded again within the project. So on the click, so you have made something, you do the visualization final to show what is happening in your case. Then you can go for the TCAE plugin, for the others, and here is the save state. So anytime you click on it, all the state which you can see in the render views, I don't know, also for example the spreadsheets, which includes, for example, some integral values for some specific evaluation. Everything is stored, and whenever you close the project and reopen again, these states are automatically evaluated. So this is in default enabled. So if you go to edit settings and TCAE part, so this enable state loading is implicitly enabled. So anytime you save and reopen the project, it will also load this state. If it makes some troubles, which we don't expect, or you don't want to have these automatic loading state, you can get you can disable it right here. Maybe let's show you how it works. So for example, I can open, for example, this radial pump tutorial. So this is the default state. I just run it before the webinar to have some, for example, to have some results. So now I just loading the project. As you can see, the residuals are there, or the quantities are there. So this is kept within the project, so it's automatically loaded. And now, for example, so I will, for example, change the view here. I will open new layout, click render view. I will visualize the results. So I will display new results. Okay, so for example, just the internal mesh, and I load all the fields. What I can do, for example, is some kind to do the opacity and then create a slide just in the middle, let's say. So yeah, it has z-axis. So just to go to the middle of the pump, apply. Okay, so this is my visualization. Okay, here I will visualize the velocity. And all right, just to speed up. Okay, so this is fine for me. So I can go back here to the TCAE manager, go to the others and save the state. So now all the layout and the renderings are saved. And now if I close the project and reopen the project again, so then also the state is loaded automatically, and I can come anytime I can come back to my previous visualizations of my project. So there is no need to re-render it again or render it separately in the plain paraview, which can hold the states without the project management of TCAE. And as you can see, still here, it loads where I stored the save state. So I think it's a really nice feature for the users, because it really store the layout of the windows, all what is done. So some kind of integral variable spreadsheets. If you go for some specific evaluation of pressure at the different slices, or whatever you do basically in Paraview and within the project, then it is stored within the project. Whenever you restore or purge the project, the state is also restored and purged, because if you restore it, the results are gone. So therefore also the state has to be erased, and you can start again storing the new save state. Yeah, so this is brand new, and I think pretty useful feature. So save state remains within the project. The next and our biggest challenge was to switch from OpenFOAM 8. It was some version of OpenFOAM 8 between 8 and 9, and now we updated to the latest OpenFOAM 13 version. So as you can imagine, we used the older version for more than 3 years, I guess, maybe more. So there were extreme number of changes in OpenFOAM code. There was a redesign of several parts of the code. So there were a lot of work to implement it, to update the CA processor, to work with the new structure, new features, etc. So this was I think 70% of the all work we have done on the new release was connected to the switching to the newest OpenFOAM version. So what it brings, the main change is that AMI was replaced by NCC, the non-conformal coupling interface. For those who are not familiar with it, you can go for CFD direct pages and learn what have been implemented. So in the older version, there was arbitrary mesh interface to connect the different parts of the meshes, or basically two separate meshes. In our language, it's components. And for non-overlapping interface, there was ETSME, which we haven't used for the older version, and now everything was re-implemented and put under one framework, which is called NCC, non-conformal coupling. I will tell you details on the next few slides, but mainly the changes were done through the accuracy of connecting and how information travels, or how information uh, uh, is processed on these two sides of interfaces, and the accuracy now is much higher than for the older AMI approach. OpenFOAM also ends the application solvers, and it started to do the modular solvers too, because in the older version there was maybe more than 100 of different solvers, and now it was somehow simplified, that it's not the solvers anymore, it's the modules. So there are lower solvers, and the physics can be enabled by the modules, if we can call it in this way. So we also need to re-implement all the solver details and how it works with them. So this was the, let's say, second biggest change between the OpenFOAM versions. Then transport and thermophysical properties were switched or unified under the physical properties. FI options for the new sources, some of physics, for example, implementing the porous media, Schneersauer for cavitation, passive scalars, etc. So now are modeled or bring into the solvers by the FE models, and for bounding tools and some advanced metrics let's say modifications are now FV constraints file, where all these features can be are designed, or basically are defined. Similarly holds for the functions. So the functions are not directly implemented within the control dict, but it has its own separate file. So in the functions, we call these our efficiency probes, interfaces, and all these processing and post-processing functions. So this must be also changed. Because of the NCC, it brings new, let's say, new format of storing the mesh on this conformal interfaces. So we need to redesign also the mesh management, the storing the meshes, visualizations, the runtime writing. So this also requires heavy development to bring it back to the TCAE. There were several boundary conditions update, changes, etc. And all of this needed to be done, or have to be re-implemented. So our OpenFOAM code needs to be re-implemented. CA processor which manages OR needs to be re-implemented, and of course the workflow updates. So workflow changes. So some steps are now done in a different way, but let's say 80% of these changes are hidden for the users because it runs automatically on the background, but some are visible for the users. But let's say maybe more than just 10% are visible and less is hidden on the background and works as usual. Now we are coming to the new features. So for the T-mesh, we have bring back or we allow user to also assign the patch not used within the component. So this is a nice feature for some modular geometries. So if you have several variants of the geometries, so in the new version you can load all of them, and for those who are not used, you can select the not used, run the project, then store it as a new one, and just select the new project or the new STLs and continue with the new simulation with updated geometry. So this was also one feature which was asked from our customers to be implemented. And how it works, maybe I can show you on this Driftwire tutorial, which is a nice example of it. So Driftwire is a model for testing the codes. It includes the model of a car of different types: estate, hatchback, notchback, etc. And now in this version, if I go, so I will just enlarge the view. Here you see the model. So this is, for example, now I have the estate model, but if I go to the T-mesh, to the components, so we load all the STLs for this model. So now if I would like to go not for the estate, but for example, fastback, so I can, the actual body I can select as not used. So simply I deactivate these parts, then the windows. So we can see this is a modular, and now I can enable, for example, this fastback body. So I will set it as wall, and now I add the windows. And instead of simulating the estate version, I can go directly for the fastback version. Now I can click save, and run the whole workflow again. Yeah, with this new geometry. So there is no need to reopen the project, reload the new geometries, because if the geometry has different names, then you need to redesign or reset the parameters of the meshing. So now you can have set everything and just switching the part of the model. So this is the example of not use, which was not available in the previous versions. So this is not used for the T-mesh. Let's go on. Now we are finally coming to the biggest changes, which is also visible for the user. So instead of AMI interface or AMI approach, now you everywhere will see the NCC. So the NCC is now switching, for example, when you are setting the internal these AMI approaches, for example, for turbo machine design, where you have some periodicities. The older version has this rotation AMI. Now it is rotation NCC. So this is the first where you can see. And for the connection of the components, now there is no AMI, there is NCC, which has two type of interface connections, so overlap full and partial, which I will explain on the next slide. So everywhere AMI is AMI, and it's ACMI, which we haven't used in the previous version, are now replaced by NCC. It is more robust implementation and more accurate implementation, as you will see in the next slides on one of our example. And it is applicable both for fully and partial overlap patches, which was not possible in the previous version. So now it is possible to apply it also when the interfaces are not fully overlapped, as you will see on the next example. And for the users, which is good, the workflow remains almost the same. except that if you go for the partial overlap interface, you need to switch your overlap from full to partial. Here's the example. So full versus partial overlap. If you have, let's say, standard radial pump with full overlapping interface, then the mapping interface is NCC and the overlap is full, which is the default. So basically, if you set it from the scratch, like the previous pump, then everything remains the same. But if you have some type of partial overlapping interfaces because of some holes in the impeller or whatever, so depends on the topology. So this little, let's say, partial, artificial geometry, which demonstrates the applicability. So I have this simplifies impeller, which just partially overlap the outlets from the impeller to the interface of the, let's say, volute, and the volute is also just a half of the volute. So now even this topology can be simulated. Here you can see the example of it, how it behaves. Maybe I have some video here. Okay, again, the advertisement. Okay, so basically now the flow goes only where the interface connection is uh, overlapped, and on the rest it's set the wall, something like wall boundary condition. So at every time step it works that at the overlapping parts it works as the usual interface, and at the non-overlapped parts it works as a rigid wall. Okay, so it switched already to the previous video. Okay, never mind. But it was just the visualization of what you can see here on this small GIF animation. Okay, now about the accuracy. So for the AMI, the interpolation was not so accurate because, for example, if you imagine two non-conformal interfaces. Non-conformal means that there's different mesh on these both sides of the interfaces, so that there are inaccurate, for example, inaccurate velocity mapping or interpolating, which causes mainly for transient simulation big oscillation at the interfaces. So these oscillations are typically made that if the impeller a little bit moves with the time step, then the mesh overlapping or mesh mapping on both sides changes a little bit, but the original approach doesn't take into account all the aspects of the changes of these meshes, like the normals, etc. And it results, I think those who run the transient simulation can see such oscillations. So this is the comparison of AMI and CC on the very same mesh. Basically, this is comparison of TCAE 25.10 with 26.03. The red one is the evolution of the head on the top graph, and on the bottom graph there is the efficiency. So we can see, as in the previous version using AMI, these oscillations were pretty huge, pretty significant. And now I have another examples with the finer meshes. So this is the roughest mesh, this is finer mesh. So you can see, because the accuracy was connected to the refinement of the mesh, and the AMI, you can see as we refine the mesh at the interfaces, the oscillation diminishes, but still with the NCC, there are no oscillation even for rough meshes, very rough meshes. And you can see the results are the same, and only AMI approach was improving these oscillations. So only on these meshes, if you can see it, it's almost solid color, but it's still very fine mesh on it. You can see still there are small oscillation, but you can see the physical oscillation of the impeller passing the volute or whatever it is caused by. But you can see that mainly for these very fine mesh, the results are comparable with NCC on the very rough meshes. So this is huge improvement for for the accuracy and CFD simulation, mainly for transient, but also for the steady state. There is significant improvement. So this was NCC, AMI versus new NCC approach. Let's coming to the next new feature. So we redesigned the reference value section, or we created the reference value section where you put all these reference like pressures, temperature, and dynamic viscosities, and wherever these parameters are needed, then are filled, and there is a link back to the reference values. So you only put these numbers in one place, and whenever any model needs these parameters, there is a reference to them just to see it, what value is used. And whenever you need to change it by link or just scrolling back, you can redesign these reference values. So this is the original version, right? When you put the reference density only here, and for example, if you click here on the custom saturated vapor pressure, or where you need to define some values or temperature, then you need to put it in that window. But here everything is on one place, and there is a reference just to see which value is used for the particular model. So this is another simplification for the user and make it more user friendly. Then we implemented new rheology viscosity models. So in the previous version there was just one model. Now we have two models, basically, one Newtonian, one non-Newtonian, the shear-dependent dynamic viscosity, which were mainly implemented because of our long-term project with the university about the axial blood pump optimizations. So now you can choose for the incompressible flows also the non-Newtonian model for the viscosity, which is this one. So you can also see this one. For those who are interested in such application, we have this study of axial blood pump, so you can go through it. We already have nice cooperation and nice output in a scientific paper, so you can go for it and get more information about it. The similar simplification was done also for the Sutherland model, because in the Sutherland model, in the open form way, you need to put both two parameters, this Sutherland temperature, I think it's called Sutherland constant, and this AS parameter, which goes from the Sutherland model for the viscosity, which is given here, which can be redesigned in this AS parameter. So OpenFOAM uses this one. So originally we implemented in the same way, but now for make it simpler for the users, we redesign it to the way that you need to just define the Sutherland constant, and the original AS is automatically computed from the reference viscosity and the reference temperature. Yeah, so from the newest version, you just need to put the constant value, and the rest is redefined using the reference values in the new reference section, and here you can see the values. Yeah, so this is the simplification. So I wanted to emphasize this for the users who already use the older version to know why these changes is done and how. Okay, the next new feature which we implemented is volume of fluid simulation. So we enable this physics for incompressible fluids for now. The interface is pretty simple. In the multiphysics, you just click on the multiphase volumetric VOF and just put the parameter of the second phase as a standard way, and the original phase, the primary phase, is still defined within the fluid properties. Then depend on the topology. If your domain is closed or open, you define the value at the inlet, or and or you define the initial value here in the initial conditions. So second phase volume, you can define it again as a several implicit shapes like box, sphere, cylinder, or by some closed STL. STL. We have several new examples. We have this maze for fun. Yeah, so just put, when I click on it, right? So here you can play with it just for fun case where we put water on the top and look how the water goes through the maze to the bottom. So this is one example you can play with. The second one was during the Christmas. We played with this Pythagoras cup simulation. So you have one inlet, one outlet somewhere at the bottom, and basically such a simulation are now also uh, can be simulated. And the final one is the Russian impeller, which is the full CFD application there. So you can also simulate these kind of simulations. So you can go for it and really simulate what you need with within this application. Yeah, so the Russian impeller I think is the most relevant example for the multi-phase simulation available on our web pages. Next features are connected to the FEA. So we've seen some lags of the mapping FSI and interface, so mapping CFD data on a FEA mesh. So just to see how mapping is done and what was mapped, we implemented that all mapped values can be now visualized. So you can visualize depending on what you met. If it's just forces, you can visualize the forces, but also newly this HTC coefficient and the reference temperature, which belongs to this HTC mapping. So maybe I will show you later how it can be visualized, but it automatically, these values are automatically stored, and whenever you display the results, you are able to visualize also the input data, which is important just to see with which data the FEA results were simulated. And connected to this problem, we implemented the new mapping tolerance. So FSM mapping implicitly uses the algorithm which looks for the faces to be mapped. So there is algorithm which is based on the local sizes of the FEA mesh of the CFD mesh and looks for the faces which are in the neighborhood of the face and in a close neighborhood, because you can imagine if you have thin solid, you would like to map it only on the inner side, not on the outer side. So this must be really accurate. But for some application where the accuracy of the input data is not perfect, so for example, here you can see some manifold-like simulation where these blue contours are the solids and the red contour is the CFD boundary, and for some reasons there is not good uh, alignment of the input data. It may happen because you can't generate the new data or better data, so the automatic algorithm fails where these distances of the interfaces are too large, which now you can visualize, and you will see such a holes, let's say in the FSI interface visualization. And now there is the option to enable the custom mapping distance, both directly in the FEA or in TCAE for mapping on external meshes for additional usage in additional tools or softwares. So now you can define the fixed mapping distance, and then algorithm changes that it looks up to this distance to try to find the corresponding face from the on the CFD side and on the FEA side. And within this, it is possible to also map properly the FEA and CFD part, which has not the best alignment of the input geometry. So this can be also done. And maybe I can show you how it works. So here I have a computed manifold multi-inlet tutorial. Okay, so let me load it, the project, the computed project, and then let me show you quickly how this can be visualized. Maybe first, if you go for the TFEA, for the simulation and finite element analysis, so here you can add this custom mapping distance if you would like to enable this user-defined mapping distance. And to visualize the results, we can go here, and now there are two types of results. So display new. First, you can visualize just the mesh, which was the input for it, and on this mesh type output, you can visualize the FSI interface. So basically, the corresponding patch or interface on the FEA, which will be used for the mapping of other quantities. And because the FEA is one patch, so we cannot explicitly choose the inner boundary. So for example, what you can do is to visualize the legenda, and then here you can click on enable opacity for mapping surfaces, and now you see just really the colored interface. It means FSI interface are the faces on the boundary with value 1. And now you can just play with the opacity just to also see the solid, etc. So in this way, you can nicely visualize the FSI interface, or okay, I can put it here into the same window, or you can visualize also the mapped quantities. So if I display new, but now the results, I will click apply, and I will get rid of the mesh. And here in these quantities, you can see that I have this HTC coefficient, and again, what you can play, enable opacity and play with the visualization. And if you little play with the values, okay, for example, in this way, all right, I make the simulation very quick, just for a few iteration, and there are some numerical errors. But anyway, in the same way, you can visualize also the mapped quantities like HTC or the temperature on the FSI interface. Okay, so this was quick demonstration of how to visualize this TFEA-like results and FSI interface. And I think we are basically coming to the end. Yeah, one new feature, that if you want to map map the CFD results on external mesh, which is particular for one of our user, is that here you can enable, sorry, I need to go to TCFD post-processing. Here you can map it on external meshes. So just put the ENPAM mesh here, and it can be mapped on your Abacus mesh, and it can be taken from the project for the external usage. And sometimes you just need to have several versions of these meshes, so several variants of geometries with the same inner part. And because within the workflow, you cannot run it just without running the whole CFD module. So we have implemented a command line option where you can put the command C processor. For those who are familiar with it, you just put the project, you just apply the new parameter of the external mesh in it. You save the project and just tell, okay, just map the results on this new mesh, and automatically it generates the data data file or directory with the files, and you can take it for next post processing. So mainly I need to say hi to Daniel, that mainly this is for him, but anyone can use it within the workflow. And the last one, as Lubos already pointed, we have dozens of tutorials. So we bring new tutorials which showing the next additional applications like this human upper airways, this non-overlapping or non-overlapping application, Rushton impeller for volumetric, for multi-phase, and a cyclone separator, so application for for particle simulation. All of these can be found on our web pages. So for example, is human upper airways. You can go for the case studies and go through the tutorials. And I hear that Lubos is already coming because I am maybe too late, but I am at the end. And now we can go back to Lubos to conclude and have the Q&A. Okay.
Hey, Radek, yes, no. Take as much time as you need. And anyway, thank you very much for your part, for your contribution. It was impressive. I followed carefully, so thank you for
Good.
it. So do I take back the presentation?
Okay, yeah.
Okay, I will.
If you have
I
some
will.
slides to conclude, yeah, and then
Just two of them, but okay. Still, we have. Yep, we have work to do. So this was Radek's part, if I'm right. And now let's switch to Q&A. So I would like ask the audience to ask your questions. We'll be happy to answer a couple of them or the most relevant for everyone else. And yeah, and let's do that. We already have a couple of questions. So Radek, please serve yourself. Just pick one if you like one. I have read a couple of them already. Some are too specific.
okay.
So yeah, I'll take one. I'll start. So for example, Assad is asking which TCAE module is best for solving 1D heat transfer problems in materials with complex internal structures. How would the new module address this challenge compared to previous versions? Well, maybe we should say that TCAE is primarily designed for 3D simulations, right? It's possible to do 2D. It's even possible to do 1D in yes, special with special boundary conditions, but well, it's difficult to say, but I would say it's yeah, likely it would be difficult. So maybe let's get in touch via email anyway. So TCA is primarily 3D CFD, finite volumes, Navier-Stokes in it. We can do quite a lot of heat transfer, but not everything. So let's discuss this a little bit more in detail. Yeah, thank you for this one. Okay. Kirit Kumar is asking, good morning from Northeast USA. Congratulations to the new release. How likely TCAE users will be impacted by ongoing AI interference in the next 3 years? Again, it's really difficult to answer anything about the future, right? Because the future is difficult to predict. What we have now is we follow trends, and trends are obvious. More and more AI is used. It's easier to implement new code. It's easier to save the data and use them for machine learning, and it's easier to learn the software, things which were before impossible due to large language models, and it's easier to automate. So it's obvious that the future for engineers will be more about understanding the product and based on engineering simulations do better decisions, right? It will be less about clicking and understanding the software itself. But that's only what we think, but nobody knows the future. It's impossible to predict, and we've always been so far we've always been wrong. So let's see. But the trends are clear, and we're happy to discuss them. So yeah, contact us anytime, and let's this thought experiment. Let's continue with it in the future. Radek, did you get your some stuff you would like to answer? We have quite a lot of questions, but a lot of them are very
Okay.
specific.
I think we have a little problem because as I'm just a panelist, I don't see the questions. Maybe
You
it's a
can
new
see the
feature.
questions.
Yeah, it's
Oh,
maybe a new feature of GoToWebinar.
yeah.
So
Well,
I think
well.
only you see it.
So
So just ask me if
sorry, Radek.
via.
I can do. I think I in this comment I can do miracles. I can click Radek now,
Okay,
and I
okay.
can. I think I can. No, in another window, make organizer. I just made you organizer. So yeah. So I hope you can see them. It's an icon with question mark on the right
Okay,
hand
okay.
side corner. Just make yourself comfortable. Read a few of them if you want to answer them. I've definitely seen more.
Okay,
Uh,
okay. I think oh now it's reloading. Okay.
Pavel Kotalik has a question. TCAE equals what? It's what? It's a system. It's software, and it's an important partnership by the way in the future. Dark theme, light theme. No light theme. We have everything is hard coded in the Qt, but you can change it. There's the style sheet in the TCA installation. In Linux it's easy. I'm not sure about the Windows. Yes, yeah, we have a lot of fun here. A couple of yeah, funny comments. What's this? Sava, yeah, hi, nice to meet you. We've been in touch lately. When restoring from older cases, AMI to NCC switch, do we need to recreate the case? The backward compatibility should be okay, should be conserved. But yeah, hopefully, yeah. No need to redesign. So
Okay, I
Henrik
have one
Malta.
question maybe. I have one question from Zachary. Is it possible to use NCC interface method to connect two statoric parts that have different periodicities? Okay. So in general, you can connect two interfaces which are not perfectly aligned, or basically one part has a different shape of another part in sense of the interfaces for connecting the component. If you would like to connect the periodicities via some transformation by the given angle and are not matching, it I think in general possible, but in the current workflow it counts that it is fully overlapped periodicity. So I think it's maybe for the further discussion, but now I think what you are asking for is also possible within NCC. But I can imagine exactly what you mean, the shape or the topology, but at 90% yes is my answer.
Okay. Yes, we have actually a lot of questions here, and
Which is great.
that's great. Thank you for your interest, but those are difficult to answer. Yeah, Dragos, hello, Dragos. Yeah, we've been in touch too lately. Is VOF and non-Newtonian rheology supported together? It's actually a question we solved recently, and we decided not to support it. I think because it would be strange. So I don't think no it's not supported yet, but anything is possible for the future. So this but it would be strange, a little bit because the non-Newtonian behavior has been only observed for liquids, etc. So there are questions. So VOF does not say what's liquid, what's gas. But we could discuss this for sure. We can
And
script anything, right? Maybe
okay,
we didn't say it, but TCAE can script anything. You can use anything which is in open form. It can really do a lot of stuff with Python scripting. So
yeah,
it's
as
very
usual.
flexible in these
Yeah.
terms.
And just let me add to the backward compatibility. So if you load all the project with AMI, it's automatically converted to the NCC
Yes.
fully overlap version. So there is There's no need to recreate, just import the older project, and automatically within the first save, it is automatically transformed to the NCC with automatical fully overlapped version, because AMI was only fully overlapped version. So there is full backward compatibility.
Okay, I think maybe I think it's time. We have a lot of questions, but don't worry, we will read them carefully and answer all of them. And anyway, you can send us your questions anytime later, and we will of course do the same and carefully use all of them. We have also CAE forum which we serve, which is public, so you can use this CAE forum for questions and answers. It's also very useful. And I think, Radek, this could be it. I think this could be it for today. I can hear from the other room. There are always, it's crowded, full of our
Okay,
colleagues running for the party. So
I'm
we
back.
want to make it right. So let's wrap this up. This is really it for today, for now, but not for. It's just for today. So we're looking forward to tomorrow. And we would like to thank you for your attention. It was a pleasure. Definitely let us know how we can help you. It's our job and a pleasure. So yeah, let us know, and we will do our best.
Great. Nothing to add. Thank
So
you very much for your attention, and let's stay in touch for
okay,
the
yes,
future
this really could be
webinars.
it. Yep. Yeah.
Thank you.
Okay. Thank you very
Take
much,
care.
and
Thank
bye
you very
bye.
much. Bye bye.
Thank you. Bye bye.